Welcome back, pre-calculus. Let me fix this part here. I had to remake that video, made a mistake. Yep, it even happens for teachers. All right, first of all, we're going to get to 7 and 8 in just a second. First, I forgot the domain and range for number 6. Hopefully you saw that it was negative infinity and positive infinity, because that's our domain and range for sine and cosine. Our range for this one went down to -5, up to +1. Use your brackets because we go through those points. All right, moving on to number 6. Let's see if I or 7. Let's see if I can get it right this time. This is a fun one. It's got both a period changer and a phase shift and a vertical shift to it. All right, so does it have a reflection or an amplitude change? No, there's nothing out here in front of the function, so we're not flipping it. The amplitude is just 1. We're going to go 1 above the midline, 1 below the midline. Speaking of midline, it's got a vertical shift up 4, which means our midline is going to be at y = 4. For our period, our typical period is 2 pi, but we got to divide that guy by our period changer, which is 2/5. When we divide it by a fraction, though, we are actually going to multiply by the reciprocal, which would be 5/2. When we do that, the 2's cancel, and that makes our period 5 pi. All right, likewise for the phase shift, a lot of you guys would say -5 pi over 5. It's -pi over 5, which I totally agree, but we've got to go and divide off. Remember, we got to factor out that 2/5. So we're going to divide off that 2/5, which means we're going to multiply by the reciprocal, which is 5/2. The 5's again cancel, and so our phase shift is -pi over 2. All right, this is a sine function. Remember, your sine function is going to start at your midline, go up, back to the midline, go down, back to the midline. Our midline for this one is at 4, so let's draw that in. And we shifted to the left pi over 2, so my starting point is going to be on the midline at -pi over 2. Amplitude's only 1, so we're going up 1 and over 1, but we got to figure out where does my cycle or my period finish, right? Well, if the period is 5 pi, if I take 5 pi and add it to -pi over 2, that will tell me where does this whole cycle end at. So finding a common denominator, that makes this 10 pi over 2 minus pi over 2, that's going to be 9 pi over 2. Well, the problem with that is we only go up to 6 pi over 2. I don't have a 9 pi over 2. My graph isn't that far out. So I'm only going to be able to get half the cycle. The upper part of the cycle will be over here. I'll have to put the bottom part of the cycle over here. Because this guy is stretched so far out horizontally by a factor of 5 there. So instead, I'm going to take that 5 pi, which is the full period, maybe, and I'm going to divide it in half to figure out how much would half of it be. Well, half of my period would be 5 pi over 2. So this is 5 pi over 2, but keep in mind we're also shifting it to the left pi over 2. So really, half of it is going to end up here at 2 pi. In other words, this graph is going to come up. Well, it's only going to come up to 1, and then it's got to be back there pi. And so now we want to look for the point that's halfway between -pi over 2 and 2 pi. To do that, I'm just going to count spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 would be halfway between. So 1, 2, 3, 4, 5. This is where I should be at my maximum height, which is 1 above the midline. Now, keeping that same logic, we can go backwards to find where we hit our minimum. So that should be at 1, 2, 3, 4, 5. We should be 1 below the midline. And then back the other direction, still 1, 2, 3, 4, 5. We should be back at our midline. And so you can see this is a sine curve, but it's very stretched out and looks something like that. All right, so for this guy, what's the domain? Negative infinity to positive infinity. That's what it is for all sine and cosine graphs. For our range for this one, it goes down to 3 and up to 5. Don't forget your brackets because we go through both of those points. All right, finally, last but definitely not least, we've got 8, which is -1/4 cosine x minus 2 pi over 3. So it does have a reflection, yes. It does have an amplitude changer of 1/4. Fortunately, there's not a period shift, or sorry, a period changer, which means our period is just 2 pi. But we do have a phase shift. So we're going to go not to the left 2/3, we're going to do the opposite, we're going to go right to the 2/3. This is 2/3 divided by the 1 there, so it's just 2/3. And that's nice because period shifts and period changers and phase shifts in the same one make it kind of messy, right? All right, vertical shift, nothing happening back here, so no vertical shift, which means our midline is right there at y equals 0. All right, so we are going to have a regular cosine graph, except when we're getting shifted to the right 2 pi over 3. So instead of my graph starting here, going down, starting here, going down, and coming back up in 2 pi, we're going to start at 2 pi over 3. So this is where my graph is starting, which means we're going to run off the graph over here again. So it might be easier for us to go 2 pi in this direction, get one nice cycle in, and then we can replicate it over here. So what would be 2 pi in this direction? So this is 2 pi over 3. I want to have 2 pi total minus the 2 pi over 3 that's on this side will give me how far over here I need to go. Maybe let's do it correctly. 2 pi over 3 minus 2 pi will give me my negative value that's going to be over here. Find your common denominator, which would be 3. 3 times 2 would be 6 pi here. 2 pi minus 6 pi would be negative 4 pi over 3. That's where my period is going to end, which is going to be here. So between this point and this point, I need to have one full cycle of cosine. Remember, cosine starts high, goes down, and comes back up high. We're still here for our midpoint. So we should be starting up here at 1, but we got to take into account we are reflecting it. So that means we'd start at negative 1, but we also have an amplitude change of 1/4. So instead of starting down at negative 1, we're going to start at negative 1/4. And that means we're also ending at negative 1/4. Now halfway between here and here, I need to be up at positive 1/4 at my maximum point above the midline. So what is halfway between negative 4 pi over 3? This would be, if I added 2 pi over 3 to it, add another 2 pi over 3, add another 2 pi over 3. So my halfway point is going to be at negative 2 pi over 3. That's where I'm going to be at positive 1/4. Halfway between those two guys is where we'll be at our midline. And so, sorry, I messed that up. This is, halfway between negative 4 over 3 and 2 pi over 3 is going to be here at pi over 3. Halfway between here and here is this point here. There's that midpoint. Let's try to make this small at 1/4. Halfway between negative pi over 3 and 2 pi over 3 is going to be right here at that pi over 6. And we'll continue it. So if you notice, we're going dot, skip 2, dot, skip 2, dot, skip 2. So here's a dot, we're going to skip 2, and here's our midpoint again. Skip 2, we should be at our maximum, which is a 4. Skip 2, we'll be back at our center. Skip 2, back at our center, heading up to our maximum. So here's what it looks like. Again, another very skinny graph of stretched out graphs. So you might think it's a horizontal stretch. But remember, a horizontal stretch is going to look like a vertical compression, and that's what we have on this one. It's really a vertical compression, but it looks very much like a horizontal stretch. What's our domain for this one? Negative infinity to infinity. Our range goes down to negative 1/4 up to positive 1/4. This is another challenging graph. You're going to have some nice, easy ones on your test, but you're also going to have some challenging ones. So you may want to practice these. You're going to get a chance to do another 8 of them in class tomorrow. Hopefully you'll be able to get further off the ground than you did today. And I'll try to make videos for you tomorrow night so that you can check your work again. Have a great night, guys.